All right, perfect. So what I wanted to create this live stream for was basically a way for me to kind of go over my homework for my students, and then additionally, so therefore we can spread up a little bit more time in class. And I decided I wanted to live stream it, not only so they can get access to this video at any time, but then also we can create some way for you to also kind of engage in some questions and so on and so forth afterwards. So this lesson is designed for just identifying the transformations of your 6 trigonometric functions. So we'll deal with sine, cosine, tangent, cosecant, secant, and cotangent, and basically just dealing with the period, the amplitude, the range, the domain, and the range of all those 6 trigonometric functions. Now, basically, if you have some questions or if you're working on something else, I do plan on doing live stream a little bit more often, and so just make sure you staying up to date with my channel and subscribe, get notifications, because I do plan on kind of rolling this out as a continued kind of endeavor to keep on improving not only my live streaming capabilities, but also to keep on offering some additional services for you guys. So before I go ahead and get started, just want to say hello to some of you that have joined. Thank you so much. I'm trying to be your teacher, Arrow, right now, and what I plan on kind of doing is just, really would like to increase doing a lot more of these live streams right around this time frame, and kind of work on not only what I am currently teaching, but also to kind of help you guys out, because I know a lot of you, have questions in your own class, and, everything that comes up, and even though the videos that I have created can be very helpful, a lot of times it's just nice to kind of have that, quick interaction. So I do understand that, and I do know that, and that's why I want to kind of offer a little bit more of my services as far as live stream, so we can kind of have that conversation, a little bit more often, and you guys can interact with me a little bit out. Sorry, Lou, yes, you may get a shout out. Welcome to the live stream. I'm happy you guys came in here. Esmeralda and Karen, thank you so much, guys. So what I'm going to do is, appreciate it, Brandon. I'm gonna go through my homework. I will kind of, again, this is designed for my own students that I'm going to be seeing tomorrow because we didn't have school today. So I will kind of work through this lesson, and if it's obviously something that you have some questions on, please feel free to make sure you type in the questions. And before I kind of move on to each and every question, I will kind of interact. If you have some other questions on some other topics, I'll kind of see how long this live stream goes, and I'll maybe be able to answer some questions after that. But otherwise, I will kind of look into increasing my live stream capabilities, where we'll kind of have a little bit more question and answer kind of things. All right. I will be doing some AP kind of questions, Arrow, when they start coming out as we start gearing up. And that's one of the things I wanted to start creating, as I know at the end of the year, we're going to start, everybody's going to be pushing for those EOCs and so on and so forth. So I really wanted to kind of, work on my live streaming, work on my setup that I have going on here. And so therefore I can create some questions and really kind of get a good setup. So when you guys come, you kind of know what to expect and you know how everything's going to go. So I really do appreciate you guys joining me here. So now I'm just going to kind of get started on my homework and just kind of work through some problems. And this is one of my first times running through with this. Okay, it is showing up. So I'm not really as used to with the tablet, so I am working on this. So, but that's why I wanted to join. So I really appreciate you guys, just kind of hanging out with me, and we'll kind of go through this together. And I always appreciate your feedback too. Once I'm done, we can kind of go over some things. So the first problem that we were working on, at least in my class here, was question number 15 for my students. They'll know exactly what I'm talking about. I need to kind of zoom in here with that, fix that 15. And that problem was y equals -3/2 sine of 2x. Okay. It's a little shaky. Let me know, because I forgot to put my blanket under my computer monitor to reduce that shake. So I kind of see, seems like the camera's working all right. But I know sometimes when I move, it kind of gets a little shake. So, hey, thank you very much, Curious George. Appreciate it. Yes, Charlene, I am going through the homework. I'm going through the homework for my students of something we covered. So what we basically want to have is we have the sine function, and in my class we've already talked about the sine graph, what it kind of looks like, and what are the kind of characteristics of it. So what I'm just going to kind of get into is really get right into how to identify the period, the amplitude, and the range in this case. So just remember that the period is pretty Um, just slow down, get that. Maybe try to write it like this. The period, just remember, for a trigonometric function for sine and cosine is just going to be 2 pi divided by b, where b is going to be your kind of coefficient of your of the x inside of your sine function. So in this case, we're just going to have 2 pi divided by 2, which is just going to equal pi. Now working into the amplitude. Amplitude is just going to be the absolute value of a, and a is going to be the constant that we're going to be multiplying by our function. So you can see here we're multiplying by our function by -3/2. So the absolute value of -3/2 is just going to be the positive form of that. So for the first problem, I always like to kind of write out everything, and then I kind of start going a little bit quicker, as we kind of move around. So the amplitude is going to be 3/2, and that's, again, just to remind you, again, the period is the distance that it takes the graph to repeat itself, and the amplitude is the half distance from the max and the min of the graph. The next thing is we're looking into the range. So actually, if we just kind of looked at this, this kind of graph, the range is if the graph, remember this function, if we're just going to look at an initial period, because obviously we know this graph continues on and on, forever, right? So here's what the graph, pi, and it's going to look something like that. It's going to cross at pi halves. So if we're looking at the range, we can see that this graph is obviously bounded, right? It has an absolute max at, that'd be pi over 4, 3/2, and then it has the absolute min over here. So therefore our range is going to be basically asking us, how low does the graph go to basically how high does it go? So our range is going to be kind of using the information off amplitude is going to be from -3/2, comma, to +3/2. And again, that is included. Those points are included, so we're going to go ahead and use brackets. The next problem here I'll work on is question number 16. Still got to work on writing those numbers. Question number 16. Oh, well, let me go and see. Does anybody have any questions, or let me kind of see what anything else. Are you still in college? I'm not sure if you're talking to me, but no, I teach high school here on there. Chocolate. Sorry, I'm nervous. It's my first time going live. Well, yeah, probably. I've gone live a couple times, but mostly my live streams have been going, in the classroom. And so when I'm teaching in front of the class, it's a very normal experience. You guys are really kind of getting a look at me when I'm teaching, at home. And obviously, to get really good at anything, you just got to do it. So just like I tell my students when they're doing math, like you're going to have troubles. There's going to be things you don't understand. But if you just keep on working at it and get out of your comfort zone, the stuff is going to start getting easier and easier the more you do it. So looks like anybody doesn't have any questions, at least on this one. So I'm just going to kind of work through this. And then obviously I'll maybe take a break after we get done with sine and cosine, which is the next 3 examples. All right, so for number 16, we have y equals -4 sine of 2x over 3. Okay, and in this case, if we want to find the period, now again, we're taking our, that got messed up. We're taking our 2 pi divided by our b. Now in this case, b kind of looks a little bit weird because we have, over here, b was 2, right? And it kind of might be a little confusing as far as what is your b here? Is it 2 or is it, the 3? So just remember that, 2 over 3x is the same thing as 2x over 3. So if we write it, though, in this way, we can see that the 2/3 is really going to be our b. So we're going to have 2 pi divided by 2/3. And when we have a number divided by a fraction, obviously we want to get good at this. Taking a little slow. Obviously we want to get good at this so we don't have to do this every single time, but we can always get rid of that fraction in the denominator by multiplying by our reciprocal. And when we multiply any number by its reciprocal, it's going to equal to 1. So therefore what we have is 6 pi, and I'm sorry for my penmanship, I'm still kind of getting used to this, 6 pi over 2, which is now going to equal to 3 pi. All right. To find the amplitude, again, that's just going to be the absolute value of a, which in this case, absolute value of a is -4. So absolute value of -4 is just going to be 4. And just in the same respect here, this graph is not moving up or down. We can look at the cosine graph. I'll kind of sketch it again, or at least the cosine graph here. If we're going into here's 3 pi, now the graph is basically going up to 4 and going down to -4. And the cosine graph starts up. See, it's going to be at, 3/2 pi. So the graph's going to come up. Dun, dun. And it's going to look something like that. Not really kind of like that, but something in that range. So Obviously, I got to get much better at this drawing thing because I keep on moving on. But anyways, you can see that the graph, or the cosine graph, just like the sine graph, is bounded. It only goes as high as the max, and it only goes as low as this max -4. So the range is not always going to be exactly the amplitude because, again, if we have, a shifting up or down, then that is going to affect things. But in this case, since we don't have any vertical translation, the range is just going to be from -4 to 4. Okay. All right. So the next one that we kind of worked on was number 62. So when we're looking at number 62, that problem was y equals -3.5 sine of 2x minus pi halves minus 1. Okay, so in this case, there's a couple things that we notice is not only do we have a b, right, which is 2, and we have our a, which is 3.5, we also notice that now we have our c and we have our d. So we're kind of incorporating two different things now. Remember, the c is going to deal with your phase shift, and the d in this case is going to be dealing with our vertical shift. So the phase shift is shifting the graph left to right, and d is going to be the vertical shift, which is going to be shifting the graph up or down. The other thing that we notice is that we have a c and a b, and what I tell my students is b stinks. And the reason why b stinks is because it messes up your phase shift. So we have to be very careful when we're completing the phase shift when we notice that we also have a b in addition to a c. But the thing I always like to tell students, when you're looking at this, let's get the main ones out of the way, or let's get the most difficult ones out of the way, or the easy ones, out of the way, and that's going to be your period and your amplitude. So just to kind of smooth along here, I'm just going to use period as p, and therefore the period here is going to be 2 pi divided by my b here is 2, so that's going to equal 2. I'll put the amplitude over here. Amplitude in this case I'm just going to represent as a, and that's going to be the absolute value of my -3.5, which in this case will just be 3.5. And again, that's saying that the graph is going to go as high as 3.5 and as low as 3.5. The graph goes down. I messed that up. I was actually looking at my work that I did in class. So now to identify the phase shift, basically what we're going to do to identify the phase shift is, yes, that deals with c, but when we have b, we have to incorporate it. So what I like to do is, it kind of gets a little confusing because these graphs continue on and on forever, right? So I think the easiest way to understand the phase shift is just to deal with the, initial period and kind of look at least a point that we have on that initial period. And the easiest point to kind of work at is with 0. So we know that sine in this case, like we have the point 0, 0. So if we set what's inside of our function, so 2x minus pi halves equal to 0. So here's, originally where that point is at 0, 0. And now I'm applying this phase shift. Let's see what happens to x as we go ahead and solve for that. So I'll add pi halves. And therefore I have 2x equals pi halves. Divide by 2, divide by 2. And again, you can think of a fraction divided by that by just multiplying by its reciprocal. So therefore, x is going to equal pi over 4. Now again, you're thinking of that shifting pi over 4. Again, that's going to be positive. So therefore, you can say pi over 4 to the right. And that does not look like pi over 4 to the right. But we're just going to roll with that because, yeah, that's all I want to do with that. So we'll just keep that going. Now, we also see that we have this d, which is shifting the graph down. So we could say that's going to be shifting the graph down 1. Now, this is important because this is different than what we covered in the last problems. If you remember in the last problem, we just kind of looked at the period and the phase shift, right? And let's kind of go a little bit farther. So the period here is pi. So, and then now it's going up to, 3.5 and down to 3.5. So if we just kind of sketch the graph here, don't need to go crazy here. But what we see here is not only this, so originally the range of this graph is negative 3.5 to positive 3.5, and I should probably use some different colors here to differentiate, right? Won't you guys agree? Actually, yeah, let me get through this. But now you can see this graph is being shifted down 1. So actually, let's kind of do that. So now the graph is only going highest 2.5, and then it's going down an extra thing here to negative 4.5. So the graph is now kind of looking something like this, right? So therefore, we can say that the range is not the values just of the amplitude like it was for these, but the vertical shift has now affected that. So now the range here is negative 4.5 to 2.5. Oh, and I thought I'd mention, I might as well go ahead and take a break here. I thought I mentioned for you guys, if you guys see me making a mistake, I'll always try to go ahead and check over there. Yes, the graph goes. But if you guys see one, please let me know, because just like when I'm teaching in the classroom, there's gonna be times that my brain will be thinking of one thing and I'll be writing down another thing, and I am very prone to making mistakes. This will be a video that I'll be making in the meantime. But when I was, in the future, but when I was taking tests, I always had to go ahead and check. I would just make a lot of careless errors, and it just allowed my brain to be thinking in so different ways. So please make sure that you let me know if you guys see something or any kind of change or any kind of mistake as I'm working through this. So last example is 65, and then I'll just kind of take a break. No, I don't want that one. Was that the one I was working with? Yeah, that's the size. Then I'll go ahead and take a break and maybe kind of answer some of your questions and kind of get a little more feedback from you guys. So 65, the last one I have here, is y equals 2 cosine of 2 pi x plus 1. All right. I love this problem because this one gets to the problems where people are like, what? I thought we were talking about radians. I'm like, where are we getting integers back again, right? And when we first get into radians, everybody's like, I just want to see integers in degrees. So I like this one because, again, we're just looking for what is being multiplied by our x. And you could say there, that is our b, which is 2 pi. And you could say our a here is 2. And then our d is 1. So in this problem, I don't know why I wasn't using colors either. It was much better, right? Wouldn't you guys agree? I don't know why I'm looking down there. That's where I can see your guys' chat. But yeah, please make sure you let me know if you guys like the colors or if it's distraction. I have a couple of questions I want to ask, but I'd like to know what you guys think about these colors. So anyway, let's go into period. So the period, again, guys, it's just 2 pi divided by b. But if you guys look, b is 2 pi. So 2 pi divided by 2 pi is 1, right? Then we go ahead and find the amplitude is just going to be the absolute value of a, which is 2. So therefore, the amplitude in this case is 2. There is no phase shift because I'm not adding or subtracting anything inside my function. And therefore, last but not least, is I have my d, which is being plus 1. So that's going to be shifting the graph up 1. All right, so if I just want to go ahead and find the range. Now, again, looking at the cosine graph here, we can now see, okay, so this cosine graph goes from 1 down to negative 1. It now has a period of 1. So that means that it completes a whole period. Oh, didn't mean to do that. All the way to 1. And it also has an amplitude of 2, not 1. So got to fix that. No. There we go. So the amplitude is 2, and that's telling you, again, the height of the graph. Now, what happens is the graph is being shifted up 1, though, right? So now it's going up to 3, and now it's only going as low as negative 1. So again, the graph should still going to cross at the same points. The intercepts didn't change. There you go. So it's going to look something like that. But now you can see that the range is only going to be as low as the graph goes, which is from negative 1 to positive 3. All right, so I'm going to put my pen down. What I'd like to do is just this is kind of halfway through on the homework. I have 4 more problems that I want to get to. Checking in the time, looking like I'm doing pretty good. I still got about 20 more minutes that I can devote to this stream. So I just want to kind of ask you guys a little questions. I'll go back and see what questions you guys have. But if you guys wouldn't mind commenting when I get to that as I'm looking through them, let me know where you guys are from. I want to see in this time zone what state, country that you guys are from. I would love to kind of hear that. And kind of see where everybody's coming from, because I am based in Jacksonville, Florida, back down in here. So I'd love to kind of see where everybody else is at. And there, close to live chat. So you are a teacher. I am a teacher, Charlene. Yes. Buckets of money to Brian. Where are you from? Canada. Well, hopefully you guys, I do plan on obviously increasing this as we start getting a little bit closer to the end of the year. We will be kind of going through that. So period is 1, amplitude is 2. Yes, very good. You got that. Shift the graph up 1. Very good. David, you got that? Good job, bud. Um, Toronto, Canada, Milwaukee, SJ, go Jags. That's right, man. We're in there. Philippines, Tennessee. You know, we were thinking about going to Toronto, Clumpy, but we ended up not. I'm actually originally from Michigan, so we're going to be back up there in the summertime. We were looking at doing a little day trip, or a couple day trip, back over to there. So yeah, yeah, my videos are available, Arrow, for my students, but they don't really use them or really care for them that much because obviously, they're the ones they see me instruct, through all of the time, and I don't know what it is. Some students have found it really valuable, and it's been great because they're ones that don't want to ask questions in class, and they just feel more comfortable watching my videos, at home. But then other question students have been like, I don't want to listen to anything or see you after school. It's like we have our time in school, and that's kind of it. So, pop quiz, well, that'd be good. And again, what I'm going to be looking for is I'm doing this live stream, and I'm going to be doing a couple other ones. And then what I'm going to do is I'm going to start asking for you guys' feedback. So I'm at this point in this stage, I'm really just kind of want to test some things, see some things, that work, things that you guys like on the live stream. And then obviously kind of, adjusting that. And especially for next year, I'd really want to kind of start next year with the ball running and knowing exactly how I'm going to live stream and so on and so forth. So you guys are really just kind of getting the initial kind of live stream and me just kind of playing around some things, see how I do. And then obviously I'll be doing some live streams, asking for you guys' feedback and kind of see what you guys think. So I really do appreciate you guys, staying in with me. I'm going to go ahead and get done with the next 4 problems. And so therefore my students that do have to watch this video, they will at least be able to get through on their homework. So now what we're going to do is the first 4 videos were just on the reciprocal functions, and now what we're going to, the sine and cosine. The next 4 videos are basically going to be getting into the reciprocal functions. And actually not just the reciprocal functions. We are going to deal with reciprocal function, cosecant, secant, but then we're also going to get into cotangent and tangent. So the main important thing, though, I want you guys to understand as far as when we're dealing with the cosecant function. So the first one is, y equals cosecant of x over 2. All right, so just remember that the cosecant is basically, this graph is looking at 1 over the sine of x over 2. So the easy way to kind of understand these graphs is just to really graph, sine of x over 2. And because if you can graph what the sine graph looks like, you can easily look at the cosine graph. And I'll kind of show you that as we work through it. But the important thing about these next 4 videos is there is no amplitude. The amplitude is the half distance from the max to the min. And since these graphs are not bounded, there is not going to be an amplitude. So the first thing we can find is just going to be the period, which again is going to be 2 pi. Didn't want to hit that button. 2 pi divided by 1/2. And then again, to simplify this, we multiply a reciprocal, which is 2 over 1, and we'd get 4 pi. Okay, so let's go and take a look at what this graph kind of looks like. Now again, we still see that there is a 1 in front of there, so that's going to be kind of important. So when we're looking at graphing the sine graph, that's going to be helpful. So I'll kind of show you what the graph looks like, so therefore we can compare the sine graph to the cosecant graph. So the sine graph is, we talked about, goes to 4 pi. It's going to cross at 2 pi. And since the amplitude here is 1, graph is going to look something like this. That's not, that's still pretty bad. Either way. So now what we want to do is we want to graph the cosecant graph, or at least just part of this initial period. A couple things that we noticed when we looked at, now we already did this in my class, so we looked at this, looking at decimals and comparing them, and what we noticed was at 2 pi, there's, for the cosecant graph, there is a asymptote there. And so for every single intercept on the sine graph, there is an asymptote. And there, so we created these asymptotes, and then what basically it looks like, it's kind of cool. The graph basically looks like it's mirrored, like it's kind of reflected, like it is the reciprocal. And oh, that's a bad parabola kind of shape thing. But basically what you have is you have kind of the reversed little parabola shape there, and then these little graphs are now approaching these asymptotes going down. So obviously the orange graph is not part of the cosecant graph, it's only the red, but it's important now that we have these asymptotes that are occurring. So that now that what we have here is basically these asymptotes as well as these kind of curvatures. So the next thing that this question was asking us is, where are these asymptotes, kind of occurring? Where is everything going in this case? And actually, let's kind of look at the range. Actually, let me get to the range first. So if we look at the range, one thing that we notice from the range is the graph is unbounded, so it's going down to negative infinity. So if I'm looking at the range, I'm going to say negative infinity, and then I'm saying how high is the graph going up, which is going up to -1. That's supposed to be a negative. And then there's kind of this dead space here. There's nothing really going on, and then it's going all the way up to 1. Oops, that's included. Anybody catch it? Nobody catch it. Brian, I have to go and vomit. What's wrong? Peace problem. Okay, well, no worries. We'll get back to this. And then over here, I'm going to go from 1 to infinity. And that's going to be the range of that graph. I'm sorry, this is question number 11. As far as finding the asymptotes, this one kind of can get some people mixed up here. So if we want to find the asymptotes, the way that I kind of look at this again is looking at, x over 2 is equal to, now where is there an initial asymptote of the sine graph? And if we were going to look at the initial sine graph, then we'd say it's going to be at pi. Now again, obviously knowing what the graph looks like is going to be helpful, but you don't have to. If you just know that there's a asymptote of the original cosecant graph at pi, and that's where I'm getting that value, now we can just go ahead and solve for x by multiplying by 2 on both sides. X equals 2 pi. So that's going to be where the asymptotes occur. And then what we can do is we can look at this graph and say that the next asymptote is occurring plus 2 pi k. Right? So whatever k is, if k is positive 1, then you're at 2k. If k is 2, then you're at 4. If you're at, k is 3, then you're at 6 pi. And it's kind of going at those intervals, and that includes negative numbers as well. So that is going to be the equation for the asymptotes, which we will use to go ahead and figure out the domain, where the domain is basically all real numbers except where those asymptotes occur. Now, if I didn't know what the graph looks like, another way that you could look at this is we know that for the cosecant and the secant graphs, the asymptotes, the asymptotes have half the period distance away from each other. So here's the period. You can see that half of the period is the distance of the asymptotes. So whatever my new period is, I'll just divide that by 2 and add that, and that's going to be my number up in front. All right, so let's get down to question number 12. Put 12 over here. Let's do another color. Let's go back to blue. All right, 13 more minutes. So number 12, I have y equals 3 secant of 4x. So looking into this, again, when we're looking into the period, again, the period for cosecant and secant is the same as sine and cosine. So therefore, that's going to be 2 pi divided by 4, which in this case is pi halves. There is no asymptote. And now to kind of identify here, notice that this, again, this is the reciprocal of cosine. So it's really kind of the same thing as 1 over 3 cosine of 4x. So if I was just going to graph, what does 3 cosine of 4x look like? So again, that graph is going to, you can see the period is pi halves. So therefore, half of that would be pi over 4. It's not a 4. This is a 4. Okay, so then the graph is going to go up to 3, down to -3. Let's pick another color. Let's do purple because we want to do purple. And so the graph is going to look something like that. Awesome. And then again, this, if you look at these, you can see these is kind of splitting this up. So that is going to be half of pi over 4, which would be pi over 8. We actually really don't care about that point, so let's not even worry about it. But anyways, what we can see here is now if we're going to graph what the cosecant graph looks like, it's going to be the same thing. We're going to have these asymptotes at where all these intercepts are. Actually, we are going to figure those out, but let's just do the math and figure them out. And then you can see the graph is going to be doing the same thing. You're going to have parabolas going in the opposite direction, approaching these. Perfect. Okay, so what was I trying to do? Oh, I'm trying to find the asymptotes. So if we look at the asymptote just of the regular cosine graph, we know that the cosine graph, if here is 2 pi, we know the regular cosine graph, this is going to be pi, so irregular crosses at pi halves. So since we have these new transformations, all I'm simply going to do is just going to take my new transformation, which is 4x. So let's write the asymptote. And that's going to be 4x is equal to the original asymptote where that would occur for the cosecant graph, which would be at pi halves. So I'm going to say 4x is equal to pi halves, and then I divide by 4 on both sides, divide by 4 on both sides. Hopefully you guys remember what we did in the last one is multiplying by the reciprocal, so that's going to be pi over 8, okay? So the asymptote is occurring at pi over 8, and then again we can see that this is half of the period distance, right? So here's the two periods. Again, we're going half of the period distance to my next asymptote. So pi halves divided by 2 is going to give you that distance. And then again, same thing, pi halves, instead of dividing by 4, you divide by 2, multiply by the reciprocal. So that's going to be pi over 4k. So looking at the range real quick, the range is going to be all to negative infinity, all the way up to -3. Man, why do I keep on doing that? -3. And then that's going to be a union. Nothing going on here from 3 to infinity. 3 to infinity. Okay, we're almost done, ladies and gentlemen. Almost got this. How do you solve? Oh, man. Okay, back. Okay, good. I'm glad to have you back. All right, let's just go and finish this up, and then I'll take some of your guys' questions here as I kind of end the stream. But I want to get through at least these questions here from my students. All right, so for question number 25, here what I have is y equals -3 cotangent of 1/2 x. Okay, so the important thing is for as far as the tangent graph is to understand what the parent graph looks like. So the parent graph of cotangent has a period of pi, intercept at pi halves, and it crosses something like this, and that is an asymptote. Okay, so again, it's unbounded, so we know that there's not going to be an amplitude. The period, instead of it being 2 pi divided by b, is now pi divided by b. So in this case, I'm just going to be doing pi divided by 1/2, and that's going to equal 2 pi. We're not graphing this. Obviously, the -3 would vertically stretch a graph, and then obviously that would reflect it about the y-axis. So if we were going to be graphing this, you would see a vertical stretch here, and the graph would be reflected, but that's not what the purpose of this video is. So we found the period. The next thing we want to do is to find the asymptote. So again, if my original asymptote occurs at pi, I want to see what does this 1/2 do to that asymptote. So what I'll do is to find the asymptote, all I'm going to do is take what's inside of my function, 1/2 x, and then equal that to where the asymptote is originally a cotangent, which is pi. And so if I divide by 1/2, or you could say the other thing is instead of dividing by 1/2, you could also just multiply. Let's go nice with some hot pink that spice things up here. So if you multiply by 2 here on both sides, then obviously you get x equals 2 pi. And then we want to see, well, how long does it take for the asymptotes to repeat themselves? And the asymptotes repeat themselves the pi, or the period. Like every period, there's going to be a graph that's repeating itself. So it's going to be 2 pi plus 2 pi k. And then obviously we don't really need to have 2 pi plus 2 pi k. We could easily just rewrite this as x equals 2 pi k. And that'd be a simplified version. As far as the range, we can go from -infinity to infinity. That wasn't supposed to happen. So -infinity to infinity. And the domain would be all real numbers except for where the asymptotes occur. So it'd be all real numbers except x cannot equal 2 pi k. But for the sake of time, I'm just going to move on to the last one because I really want to get to you guys' questions and kind of see what you guys have here. So the last one is the tangent function. Y equals negative tangent of pi halves x plus 2. Now notice the pi halves and x is going to be inside of the function. Okay, that's very important. And so again, we want to find the period. So I do p equals, again, let's go and look at what the graph looks like. So tangent is different than cotangent. Let's do something a little bit straighter. So tangent has asymptotes at a little bit different than 0 and pi, which is kind of nice about cotangent actually. Is the graph kind of looks something like this. That's supposed to cross at 0, 0. You have a nice little vertical asymptote here, nice little vertical asymptote here. Graph continues down and on from there. So there's your asymptote. So it still has the period of pi. And so we're defining the period. We're just going to do period or pi divided by b, which in this case is pi halves. Now, this one doesn't look like it's going to be fun multiplying by a reciprocal, but it's really not that bad. 2 divided by pi, that obviously just goes to 1. So we have pi divided by 2 over pi. Well, again, the pi's divide to 1, and we're just left with a period of 2. So now, the graph is going to extend from, negative 1 to, 2. And then we have a d, which in this case is positive 2, so that means the graph is being shifted up. I'm just checking. Okay, so the graph is being vertical translation is up 2. All right, so let's go ahead and find the domain. Now, in this case, you can see there's original domain at pi halves. So my domain is now going to be what my new transformation is compared to pi halves. So therefore, I'm just going to take whatever's inside of my function, pi halves x, equal to the new pi halves. And now you can see x, if you obviously divide by pi halves on both sides, you just get x equals 1. And then again, it's going to be the distance of the period. So this graph is going to repeat itself every period. So therefore, it's going to be 1 plus 2k. And obviously, we want to keep that 1 because that's going to be basically giving us all odd numbers. In that case, 3 and so on and so forth. So the range is obviously negative infinity to infinity. So there you go, ladies and gentlemen. That is completing of the homework. Thank you for all of you guys that stayed. What I'd like to do is just kind of take a look here and let's see how much time I left. Well, I have about 4 minutes that I can answer some questions. So for any of you, those that are still there, I'll be love to. Dante's lint roll, yes. Okay, I see your frustration. I apologize for all of that. Math is not meant to elicit those feelings for you, but I do understand some of those things. Henry, we're going to get into solving trigonometric functions. That is one thing that I will be coming into. I would say, though, for your problem, you are definitely going to want to combine those into and then get them into one trigonometric function. So let's actually, I don't want to, what is this supposed to do? Let's go and play around with that because I haven't, it's been a while, Henry. So I'll go ahead and try to play with this. Let's kind of see what we can kind of come up with. So